This video will go through some solving equations and it will just expand on what we previously learned with solving equations. So solving equations again is finding the value that makes an equation true. So we're always trying to find the unknown variable, the unknown number of the variable. So here an example, we want to find what is x. It doesn't have to be x, it's whatever the variable is in the question. We want to find what is x that makes it true. What makes the left side of the equation equal to the right side. Okay, and we want to solve for it. We don't want to just do trial and error, so we follow some steps. So in example 1, it says to solve. So again, we're trying to find, this means find the value of the variable. Value, in other words, number of the variable. Okay. So x minus 4 equals 9. I want x by itself. So I want this minus 4, this negative 4 to disappear. So I'm going to add 4 to it, and that makes that 0. But I know that I need to keep things balanced, so I'm going to have to add 4 to the other side as well. When I do that, minus 4 plus 4 becomes 0, so I just write an x here. And then I'll do 9 plus 4, which is 13. And there you go, I've solved it. I've shown my work by showing what I added to both sides. Now we know the opposite of subtraction is adding. Now the opposite of multiply, so it's negative 5x means there's 5 x's. Okay, so I'm going to divide both sides by negative 5 because that's multiplication, and the opposite is multiply is divide. So negative 5x divided by 5, negative 5, that's just x. Negative 5 divided by negative 5 is just 1. And then 15 divided by negative 5 is negative 3. Okay. Again, I've shown my work by showing that I was dividing both sides by negative 5. Now, in some situations, you need more than one step to solve the equation. In these cases, we always perform the operation in the following order. First, we add or subtract a number from both sides. So it's opposite of what you would think from order of operations. And second, we multiply or divide. First, we add or subtract a number from both sides of an equation. Secondly, we multiply or divide both sides of an equation by a number. So here are some examples that support this. So we want the x by itself, and we have a number beside it here. I want to get rid of the number. I want that positive 3 to disappear. So I'm going to subtract 3 from here, which means I'm going to subtract 3 from both sides, the other side. So that just leaves me 2x here, because 3 minus 3 is 0. And then I'll do 5 minus 3, which is negative 2. And then I have this 2 beside the x, so I can divide by 2 and divide by 2. That leaves me with x equals negative 1. You'll notice first we added or subtracted, and then we divided. So we're following these steps that we were given. Okay. And now I know x equals negative 1. If I plug it in here, oops, oh, by looking at that, I realized I made a mistake. That should have been 2. Because 5 minus 3 is 2. And, sorry, 2 divided by 2 is just 1. That makes more sense because if I put 2 here, 1 here, 2 times 1 is 2. Add 3, that equals 5. That's what makes left side equal to right side. That's how you do a check. You plug that number back into the original equation and you check if your answer makes both sides equal. So again, look here, 3x minus 5 equals 16. Okay. I don't want this negative 5 here, this plus 5, sorry, the minus 5. So I'm going to do the opposite operation. I'm going to add 5. Negative 5 plus 5, that becomes 0. And then I add 5 to the other side because I keep things balanced. So this becomes 3x because that's 0. And then 16 plus 5 is 21. Okay, so notice I added first. Now I'm going to divide both sides by 3 because I still want the x by itself. So 3 divided by 3 is just 1. So that leaves me with x. And 21 divided by 3 is 7. Okay, so let's keep doing these. Again, I want this variable by itself. So this number beside it, I don't want it here. So I'm going to get rid of it by doing the opposite operation. Negative 7, opposite positive 7. If I add positive 7, that becomes 0. Add positive 7 here. That leaves me with negative 2y here. And then 8 plus 7 is 15. Okay. Divide both sides by negative 2. And this one gives us a decimal. Y is equal to negative 7.5. Leave it as a fraction, or you can turn it to decimal. So if I plug that in here, I will get negative 2 times negative 7.5 becomes positive 15. 15 minus 7 is 8. So I just checked my work to make sure my answer was correct. Okay, same idea. I have a positive 12 here. I don't want that here. So I'm going to do the opposite. I'm going to subtract 12 both sides. That becomes 0. So this is negative 5x. 7 minus 12 is... That's it's a negative, and it's 5. And last step, I don't want to know what negative 5x is. I want to know what 1x on its own is. So I'll divide both sides by negative 5. Negative 5 divided negative 5, it just leaves me with x. And negative 5 divided by negative 5 again is 1. So again, if I check this, if I plug 1 here, negative 5 times 1 is negative 5 plus 12, that gives me 7. Okay, a couple more examples. So I usually like my variables on one side. Numbers on the other. Okay. So this here, I want to get rid of this variable on this side. I want it on the other side. So what I do is I add the opposite to it. Negative, this is so now it's positive. So that's 0 there. But as you know, has to be done on both sides to keep things balanced. So negative 4x plus 3x leaves me with just negative 1x or negative x. That becomes 0 and I'm left with negative 4. Now remember, I don't want to know what negative x is. I want to know what positive x is. So I divide by negative 1 because that's what's in front of it, both sides. And that leaves me with x equals to 4. Here we have two variables and a number here. Before I go on, let's just simplify the like terms because I can do 2x minus 5x. That's negative 3x. Now I remember I want my variables on one side, the numbers on the other. So this pause for, I'm going to subtract 4 from it, makes it 0 there, and subtract 4 on the other side. This leaves me negative 3x equals negative 9. And lastly, I still want to know x by itself, so I divide both sides by negative 3, and x is equal to 3. Okay, and there you have some solving equations. Watch the next video for more details.